What we're going to be looking at today is one of the behaviors of light known as refraction. What we'll be using is a ray box. Now the ray box has got a lamp in there. It's got a battery attached in my particular model here. When I switch on, you can see it makes a bright light. What we'll also be using is this slit. We're going to use this single slit placed right at the end to produce a single ray of light. And we're also going to be using a perspex block. Now perspex is just a clear plastic. This one's painted on the underside white to make it easier to see the light shining through it. Place the perspex block on the paper, and I'm going to draw around the perspex block. This is so that we can make a permanent record of what the light did when it went through the perspex. We'll be marking out the path of the light, and this means even without the ray box we can see what the light did. Next, I'm going to take my ray box and put it at an angle, shine a ray of light through the perspex. What I need to do is mark out where the light originated from, exactly where the light hit the perspex block, exactly where the light came out of the perspex block, and then a mark to show where the light ended up going. Once we've done that, it's simply a matter of removing the block and joining the dots together. Now we can see my first dot was here. So I'm going to use a straight edge, either a ruler, in this case I'm using a protractor, and join it up to the dot where it hit the perspex block there. So using my pencil and my ruler, draw the ray of light. So this is where the light originated from. We call this the incident ray. An incident is when something happens. Well, this is where the light was happening. It's incident there. Next, the dot where the light hit the perspex, I'm going to join to the dot where it left the perspex, which is there. And finally, the dot where it left the perspex here, and the dot for where the light ended up going over here, I'll join them together. Now this diagram now shows the path that light took. You might notice something odd. The light is not going in the same direction at all times. If I line the perspex block up here with that ray of light, you can see that it's actually bent downwards. Similarly, when the light was moving through the perspex, if I line this perspex block up with the line, you can see, oh look, it's bent away from its original trajectory. What's going on? Well, let's measure it all out with a protractor. First, I'm going to line up my protractor. I'm going to find 90 degrees to the surface. Now, the reason I'm doing that is we always measure the angle of light, either reflecting or refracting, to the normal. We usually represent this as a dotted line. So the normal is a line that's perpendicular to the surface of the medium in which we're investigating the behavior of light. So this line we call the normal. So the normal is at 90 degrees. What I can now do is measure the angle of incidence. This angle of incidence is the angle at which light hit the block compared to the normal. So using our protractor, I'm going to lay it out so that I can measure the angle. So 10, 20, 30, 40, 55 degrees. It's 55 degree angle here. 55 degrees is what we call the angle of incidence. The angle of incidence is the angle at which the light ray is hitting the block compared to the normal. What we can also measure is the angle at which the light travelled after passing through the surface of the medium. So again, line up my protractor carefully. I'm measuring the angle to the normal. The normal is at 90 degrees to the surface. So this is my angle I got. And I'm just going to use my protractor to measure that angle. And I get 10, 20, 30, 34 degrees. So 34 degrees is the angle of refraction. The angle of refraction is smaller than the angle of incidence. And this happens every time light moves from a less optically dense medium, in this case air, into a more optically dense medium, in this case perspex. So air is less optically dense, while perspex is more optically dense. So the light will bend towards the normal when it moves into a more optically dense medium. Well, what happens if light moves into a less optically dense medium? Well, you can see that the other side here. I could repeat drawing my normal here and measuring the angles, but it will be easier just to show you by placing the block back on here and looking at what happens when I trace the line in the other direction. So what you can see is, again, light is moving from the less optically dense medium here. Here's the perspex block. The light bends towards the normal. And then as it comes out of the perspex into a less optically dense medium, it was traveling in this direction with a small angle of incidence. It's bent away from the normal. Instead of going straight ahead, it's bent away from the normal. The normal is here, 90-degree angle. The light ray bends away from the normal. And it does that whenever it moves into a less optically dense medium. So the rule for refraction is that when light moves from a less optically dense medium to a more optically dense medium, the light ray bends towards the normal. Instead of going straight like this, it bends towards the dotted normal line here. When moving from a more optically dense medium to a less optically dense medium, it bends away from the normal. So it was going this direction, but it bent away from the dotted line there, the normal. And that's our rules of refraction